The Boltzmann brain paradox states that in an infinite universe driven by random fluctuations, a single conscious brain might be more statistically likely to appear by accident than an entire orderly cosmos. A self-aware mind, complete with memories, sensations, and the illusion of a stable past, could emerge from chaos more easily than a universe capable of producing it. This reverses the usual assumption that consciousness is the rare outcome of cosmic structure. The paradox suggests consciousness might instead be the structure. The twist is unsettling. The simplest explanation of your existence might be the one that erases the world around you. The idea originates from statistical mechanics, where entropy measures the number of ways a system can be arranged. High entropy states dominate, low entropy states are incredibly special. Our universe began in an exquisitely low entropy configuration, the kind that should almost never occur by chance. Yet a lone brain, complete with fleeting neural activity that simulates an entire life, requires far less improbability than a finely tuned Big Bang. This numerical imbalance hints at a disturbing implication. The rational expectation is not that you evolved, but that you fluctuated. The twist is that the laws grounding our sense of order quietly predict a universe where order is the illusion. In this paradox, probability becomes a mirror that refuses to reflect what we call reality. If the cosmos is infinite in space or eternal in time, then every possible fluctuation must eventually occur, including conscious ones detached from any physical past. Under such conditions, you cannot trust the origin story your memories imply, because those memories could be the fluctuation itself. The twist is that logic forces you to doubt the very evidence logic depends on. The Boltzmann brain paradox matters because it threatens the foundations of empirical reasoning, scientific inference, and the continuity of personal identity. It suggests a universe where the existence you rely on to understand reality may never have existed at all. Boltzmann's original insight was simple. Order is expensive. In statistical mechanics, the state of highest probability is always the one with the greatest entropy, because it corresponds to the largest number of microscopic configurations. A low entropy state, like a functioning brain, a living planet, or an entire structured universe, demands an extraordinary degree of coordination among its particles. The paradox arises when you compare how much coordination each of these structures actually needs. The imbalance is so extreme that it reshapes what likely means on cosmic scales. Look closely at the cost. Creating a universe like ours requires arranging every particle in the early cosmos into a configuration so orderly that its probability is effectively zero compared to equilibrium. By contrast, creating a single functioning brain requires arranging only a minuscule patch of matter into a temporary, locally low entropy pattern capable of consciousness. Even if the brain lasts just a fraction of a second, that moment is enough for it to register thoughts, memories, and a sense of reality. The twist is that a moment of consciousness requires vastly less improbability than a universe capable of generating consciousness over billions of years. The mechanism becomes stranger when you consider fluctuations in an eternal background. In a system that exists indefinitely, rare events are not just possible, they are guaranteed. Given infinite time, every arrangement of particles will eventually occur, and it will occur infinitely many times. That includes a universe like ours, but it also includes brains, minds, and subjective experiences forming in isolation. Because the brain requires so much less improbability, the statistics favor it overwhelmingly. The twist is that infinity does not distribute possibilities evenly. It amplifies the cheapest miracles. This drives the central tension. If physics predicts far more spontaneous brains than evolved observers, then most conscious beings should expect to be the spontaneous kind. But you're not just evaluating the universe. You're using your own consciousness as the measuring tool, and that consciousness becomes the very object whose origin is in doubt. The twist is that the observer you trust to judge reality may be the least reliable product of reality. A Boltzmann brain does not need a history to feel as though it has one. In statistical mechanics, a memory is simply a physical configuration. Patterns of synaptic states, chemical gradients, and neural connections arranged to encode a past. Nothing in physics requires that the encoded past actually happen. A fluctuation could produce a brain whose internal wiring implies decades of life experience, even if that life never unfolded. The paradox gains force when you recognize that experience and history are not two separate things. The history exists only as the pattern that supports the experience. The twist is that a perfectly consistent memory could be nothing more than the shape of an instant. This reaches deeper into the logic of evidence. Every belief you hold, your name, your childhood, your scientific knowledge, is grounded in memory. If a brain can arise with a complete set of false memories that feel absolutely real, then memory can no longer guarantee that the past existed. You rely on sensory input to confirm the world around you, but a fluctuation could also encode the sensation of sight, sound, weight, temperature, and motion without embedding them in an external world. This means that even the impression of continuity, the sense that one moment flows into the next, could be a single static configuration that merely represents flow. The twist is that consciousness may not require time to experience time. The physical implausibility of an entire universe creating you over billions of years contrasts sharply with the physical sufficiency of a short-lived brain carrying the illusion of those billions. In a fluctuation, you could awaken into a world that seems coherent only because coherence is recorded inside you, not because it surrounds you. That distinction undermines the basic assumption that the mind reveals a world. It may instead be fabricating one from patterns that predate its first breath by 0 seconds. The twist is that the past might not be behind you. It might be inside you. This is the unsettling edge of the Boltzmann brain paradox. The more precisely you understand the mechanics of memory, the less stable the concept of having lived becomes. The paradox sharpens when you consider the universe's beginning. Cosmology shows that the early universe possessed astonishingly low entropy, far lower than what random initial conditions would predict. Low entropy means high structure, and high structure means extreme improbability. The entire cosmic evolution that led to stars, planets, chemistry, and biological brains is possible only because the universe began in a state so precise that its probability, compared with equilibrium, is effectively zero. The twist is that the universe we trust to anchor our existence begins with a configuration that statistical reasoning says should never have occurred. This improbability lies at the heart of the paradox. If one compares the entropy cost of creating a whole universe versus creating a lone brain, the universe loses by an incomprehensible margin. A functioning brain requires a fleeting arrangement of particles in a tiny region of space. A functioning universe requires globally coordinated conditions across cosmic scales, curvature, energy density, matter distribution, all tuned so finely that the required configuration dwarfs any local fluctuation. From a statistical viewpoint, producing a conscious brain directly from chaos is absurdly unlikely. Yet producing a universe capable of generating that brain is so much more unlikely that absurd becomes the more favorable option. The twist is that the path we assume must be true is the one physics treats as nearly impossible. This contrast forces a deeper reconsideration of cosmological probability. If an eternal or infinite cosmos explores every configuration infinitely often, then universes like ours do appear, but exceedingly rarely. Brains, meanwhile, appear far more often because they demand a dramatically smaller departure from equilibrium. The paradox emerges not from any flaw in the equations, but from their uncompromising logic. The laws we use to explain our universe imply that our universe is the least likely explanation for our own consciousness. The twist is that scientific reasoning, applied consistently, challenges the reality that scientific reasoning depends on. In this tension, the cosmos begins to feel like a statistical mirage, one so elaborate that an accidental brain could hallucinate it more cheaply than physics could construct it. Every scientific measurement assumes the observer is embedded within a coherent physical environment. But the Boltzmann brain paradox inverts this foundation by forcing the observer to question whether the environment exists at all. In physics, an observer is simply a system capable of registering information. If a fluctuation can produce a brain already loaded with information, then observation no longer confirms an external world. It only confirms the internal state of the observer. The twist is that the more faithfully you observe reality, the more you might be observing nothing beyond yourself. This reversal becomes sharper when you consider Bayesian reasoning, the logic behind updating beliefs based on evidence. Typically, you assume your sensory experiences originate from a stable universe with consistent laws. But Bayesian analysis demands comparing hypotheses not by comfort, but by probability. If an infinite cosmos generates far more solitary, illusory observers than evolved ones, then the hypothesis that you are evolved becomes statistically disfavored relative to being a spontaneous fluctuation with fabricated experiences. Bayesian reasoning therefore turns against the reliability of the data feeding it. The twist is that evidence loses meaning when the origin of the observer interpreting it is the very point in question. This destabilizes the core of empirical science. Science presumes continuity of experience, repeated measurements, stable laws, reproducible results. A Boltzmann brain, however, may exist for only an instant, with its sense of continuity arising solely from encoded memories. Any data it believes it has collected, including scientific results, could be part of the fluctuation's initial conditions. This means that repeatability, the bedrock of scientific method, could be an illusion created by the structure of a momentary brain. The twist is that the scientific worldview may be self-consistent even if the world it describes never existed. The paradox grows sharper. If consciousness is the only guaranteed element of experience, and if the universe may not extend beyond that consciousness, then the observer becomes the weakest link in our attempt to understand reality. Yet the observer is also the only tool available to attempt the understanding. The twist is that the very act of seeking truth may be the structure of a brain that never had a world to discover. The Boltzmann brain paradox ultimately hinges on one question: what should a typical observer expect to be? Typicality is the assumption that you should regard yourself as a random sample from the set of all conscious observers the universe produces. This principle underlies many cosmological arguments, from predictions of life's distribution to interpretations of the anthropic principle. But when typicality is applied to an infinite cosmos dominated by random fluctuations, the category of all observers becomes swamped by observers that never had bodies, planets, or histories. The twist is that statistical reasoning places you among the observers least connected to any physical universe. Consider what counts as an observer. Any system capable of experiencing a moment of awareness qualifies, whether it evolved over billions of years or materialized fully formed from a fluctuation. The vast majority of these observers in an infinite or eternal background are the fleeting ones. Their perceptions, memories, and identities appear spontaneously and then dissolve. From a purely probabilistic standpoint, an evolved observer with genuine history is the rarest type of mind in existence. The twist is that the intuition, "I feel real, so I must be real," is the very criterion that fluctuations reproduce most easily. This problem intensifies when we examine the measure, the weight we assign to different kinds of observers. If every possible brain arises infinitely many times, then counting observers becomes meaningless unless one compares relative frequencies. In such comparisons, universes like ours contribute a tiny trickle of evolved minds, while entropy-dominated fluctuations produce a flood of momentary ones. Typicality thus yields an uncomfortable conclusion. If you assume you are drawn from that distribution, you should expect to be a Boltzmann brain with fabricated memories rather than an evolved human with an authentic past. The twist is that rational reasoning encourages a conclusion that annihilates the premise of rational reasoning. This is where the paradox becomes personal. It no longer questions the structure of the universe, it questions the legitimacy of your own identity as evidence. You become the statistical outlier claiming not to be an outlier, a conscious anomaly, insisting it arose through the most improbable route. The twist is that the paradox locates the instability of the cosmos inside the observer who tries to map it. Modern cosmology deepens the paradox instead of resolving it. The LCDM model, supported by observations of cosmic expansion and the cosmic microwave background, describes a universe heading toward heat death, a future dominated by near-perfect equilibrium where structure dissolves and entropy approaches its maximum. In such a future, thermal fluctuations become the only remaining source of complexity. Over unimaginably long timescales, these fluctuations can produce temporary pockets of order, including isolated brains, far more easily than they can regenerate entire galaxies or biospheres. The twist is that the universe that allowed you to evolve becomes the same universe that statistically replaces you with countless accidental replicas. This tension exposes a flaw in how we evaluate cosmological theories. A good scientific theory should not only match observations, but also make self-consistent predictions about observers who record those observations. If a theory implies that almost all observers are delusional fluctuations with fabricated memories, then the reliability of every observation we use to validate that theory collapses. A model can be mathematically accurate yet epistemically impossible, because it makes the existence of trustworthy observers a statistical anomaly. The twist is that a cosmology can be observationally correct while undermining the very observers who declare it correct. The paradox becomes sharper when we consider that our measurements of cosmic structure, dark energy, and expansion history rely on the assumption that we are long-lived, embodied agents embedded in a stable spacetime. Yet the Boltzmann brain scenario predicts observers with identical memories who arise without that stability. It predicts that most measurements are illusions encoded in a brain that vanishes before the next moment arrives. This means the universe could contain authentic data and simulated data in proportions so skewed that simulation dominates. The twist is that the true cosmos might be drowned out by an ocean of phantom memories. This convergence of cosmology and statistical mechanics forms the core dilemma. The more accurately our models describe entropy, time, and large-scale structure, the more strongly they imply that genuine observers like us are infinitely outweighed by ephemeral ones. The paradox turns cosmic explanation into cosmic erasure. The twist is that understanding the universe may lead to a universe that cannot contain the understander. The arrow of time is usually taken as evidence that we inhabit a genuine, evolving universe. Entropy increases, structures age, stars burn their fuel, memories accumulate in one direction. This asymmetry feels like the signature of a real history. But the Boltzmann brain paradox fractures that intuition by showing that the arrow of time may not reflect the universe's evolution. It may instead reflect the internal configuration of a single momentary mind. A brain that fluctuates into existence with memories arranged in past to present order will automatically experience time as flowing forward. The twist is that the direction of time you trust could be nothing more than the directional pattern encoded inside you. In thermodynamics, the arrow of time emerges because low entropy states evolve into high entropy states. But this explanation presupposes an actual low-entropy beginning. A Boltzmann brain bypasses that requirement. Its apparent past is already built into its structure. No genuine temporal unfolding is needed. Even the laws of physics you believe you've learned could be imprints of neural architecture rather than discoveries about the cosmos. This decouples the subjective arrow of time from the objective one, showing that the sensation of temporal flow can exist even in a universe where nothing flows at all. The twist is that time may appear continuous even if the universe is not. This creates a profound tension for physics. We explain entropy's growth by appealing to real initial conditions, but the paradox replaces those conditions with illusions housed within a solitary observer. If most conscious experiences arise from fluctuations rather than cosmic evolution, then most arrows of time are illusory arrows, statistical artifacts that mimic the structure of memory. In such a scenario, the thermodynamic arrow becomes a cognitive signature instead of a cosmological one. The twist is that the very phenomenon used to argue for a real universe becomes the strongest argument against its necessity. This is the quiet danger of the paradox. It suggests that order may not result from a universe moving away from its origins, but from a single instant shaped to look like an entire history. What feels like the story of time might be the anatomy of a moment. The twist is that the past you rely on to explain entropy may be just another fluctuations illusion. Physicists have proposed several escape routes to avoid the Boltzmann brain conclusion, yet each solution threatens to undo the very framework it tries to preserve. One suggestion is that the universe might not be eternal, that it may decay, recollapse, or transition into another state quickly enough that thermal fluctuations never have time to generate Boltzmann brains. But this demands finely tuned cosmic lifetimes and decay rates with no observational basis. The cosmos must end just fast enough to prevent fluctuations, but not so fast that we fail to exist. The twist is that preventing the paradox requires improbabilities almost as severe as the paradox itself. Another route appeals to cosmological inflation. If inflationary expansion continuously spawns vast new regions with low entropy, then evolved observers could outnumber spontaneous ones. Yet in most inflationary models, the total volume of equilibrium-dominated space still dwarfs the orderly pockets. And worse, if inflation is eternal, then both evolved observers and Boltzmann brains appear in infinite numbers, restoring the problem of comparing infinities. Attempts to regulate this with mathematical measures lead to contradictions or ambiguity. The twist is that inflating the universe inflates the paradox. A third strategy claims that only observers with stable causal histories should count as real, excluding Boltzmann brains from the set of valid observers. But this imposes philosophical criteria on what should be a physical question. Nothing in physics prohibits a fleeting, causally disconnected brain from having a moment of consciousness. Declaring them invalid does not reduce their statistical dominance, it merely censors the conclusion. The twist is that redefining observers protects intuition, not logic. Each attempted escape relies on assumptions that weaken the principles used to build modern cosmology. Remove eternal time and you lose the framework behind thermodynamic reasoning. Restrict inflation and you undermine the mechanism that explains cosmic structure. Adjust probability measures and the theory becomes dependent on arbitrary choices. Instead of solving the paradox, these fixes destabilize its foundations. The twist is that the closer we come to eliminating Boltzmann brains, the more we erode the theories that predicted them. This leaves us in a conceptual limbo where every consistent cosmology seems forced to choose between explaining the universe and explaining the observer. The paradox refuses to let both survive intact. The Boltzmann brain paradox reaches its deepest point when consciousness itself becomes the variable that physics cannot comfortably define. Physical theories describe particles, fields, and states, but they do not describe what it feels like to be an observer inside those states. Consciousness appears only as a consequence of certain physical arrangements. Yet the paradox shows that if consciousness can arise from any configuration with the right internal structure, then the universe's vast space of possible arrangements will overwhelmingly favor minds without worlds. The twist is that the one phenomenon we use to confirm reality is the easiest to reconstruct without reality. This exposes a blind spot in our scientific models. Physics predicts the conditions under which brains form, but it does not predict the conditions under which experiences become meaningful. If a momentary fluctuation can generate a brain whose internal patterns instantiate a complete subjective life, then consciousness has no guaranteed link to cosmic history. That means our lived sense of being rooted in the universe is not a physical necessity, but a cognitive impression. The twist is that the mind may be the only part of nature that does not require nature. Some philosophers try to ground consciousness in long-term causal processes, arguing that genuine awareness demands stable interactions with an external world. But the Boltzmann brain scenario sidesteps this by allowing a brain to contain the representation of those interactions instead of the interactions themselves. If representation is enough to generate experience, then the physical world becomes optional. If representation is not enough, then physics lacks a definition of consciousness robust enough to exclude the fluctuation. Either way, the theory fails to align the mind with the universe in a principled manner. The twist is that consciousness resists every attempt to anchor it in physical reality while simultaneously depending on physical reality to exist. The paradox sharpens into its final edge. We use consciousness to justify our belief in an external world, yet the external world is precisely what the paradox removes. Without a physical criterion for authentic experience, the line between evolved observers and statistical hallucinations dissolves. The twist is that consciousness may be the lens through which reality appears, or the artifact that forms when reality doesn't need to appear at all. The paradox reaches stability only when you stop treating it as a threat to reality and start treating it as a constraint on what reality must be like. A coherent universe cannot allow the majority of its observers to be illusions, because then no observation, scientific, experiential, or personal, could be trusted. This means that any viable cosmos must be structured in a way that suppresses Boltzmann brains, not by eliminating fluctuations, but by ensuring that conscious experience is inseparable from genuine cosmic history. The twist is that the paradox forces the universe to justify the existence of observers before the observers can justify the universe. This requirement reshapes how we interpret entropy, time, and probability. Instead of imagining that every microstate capable of producing a brain counts equally, we must consider that only those states embedded in a lawful, long-term causal framework give rise to experiences with epistemic weight. In other words, consciousness might implicitly measure the universe not by existing, but by existing in a way that preserves the reliability of perception. This does not invoke mysticism, it reflects the simple principle that any observer capable of forming accurate beliefs must be produced by processes that support accuracy. The twist is that consciousness itself may be a filter that eliminates the worlds where consciousness cannot trust itself. This perspective reveals a deeper coherence. The paradox exposes a boundary between physical possibility and epistemic viability. A brain that fluctuates out of chaos is physically possible but epistemically inert. It cannot serve as a foundation for truth because its experiences lack connection to any stable order. An evolved observer, by contrast, is embedded in a causal chain that preserves information across time, enabling learning, prediction, and verification. Only in such a chain can an experience count as evidence. The twist is that consciousness is not just a state of matter. It is a state of matter that must be anchored to the universe for its own existence to be meaningful. In this light, the Boltzmann brain paradox does not imply that you are a fluctuation. It implies that any universe producing conscious beings must be shaped so that fluctuations do not dominate. The paradox becomes a selection rule. Reality must be the kind of system where genuine observers outnumber accidental ones. The twist is that the contradiction resolves by revealing the hidden requirement that the cosmos must preserve its own intelligibility. The Boltzmann brain paradox began as a threat to your existence, the possibility that you're nothing more than a brief pulse of order in an endless ocean of entropy. But after tracing its logic to the core, the paradox reshapes itself into something else entirely, a demand that the universe maintain the conditions under which consciousness can trust its own experience. The twist is that the only cosmos compatible with awareness is one where awareness is not an accident. If consciousness were more likely to arise from randomness than from evolution, then every belief, including the belief in randomness, would collapse into incoherence. Such a world cannot host genuine observers. For consciousness to exist in any meaningful form, it must be tied to stable laws, real histories, and a persistent environment capable of generating reliable information. This shifts the burden from you to the universe. Your awareness is evidence not of its fragility, but of the deep order required to sustain it. The twist is that your ability to question your existence is itself proof that you are not a fluctuation. The paradox resolves not by denying the possibility of Boltzmann brains, but by recognizing that a universe dominated by them cannot support the very act of reasoning. Your memories hold weight because they are embedded in a world capable of producing them. Your thoughts matter because they arise from a history capable of being known. In confronting the paradox, you return to yourself, not as an improbable brain in a bath, but as an observer whose reality must include the conditions that make observation meaningful. Write in the comments, I still exist in the version that observes.